I forgot to get the music queued up. What music am I going to play today? Just go with the classic stuff. Okay, I'll play, I guess, the volume mark, right? Why do I... Is my... Oh, my volume is low. No, this is the annoying part of doing the music, which is songs usually start quiet. I think it's too quiet, though, still. Oop. Damn it! I got tricked. Okay. I think that's a good volume. Tiny bit lower. I think where I first put it was actually good. Tharv, because I can't answer every question. About all the thought that went into it. Okay, so the quest to learn R continues. Where I left off last time off stream was learning about facets. I don't know why you need a fancy word for this, but it's basically creating a bunch of subplots based on, usually you use a categorical variable. You could do a continuous variable, but kind of weird, and why would you? I think I was stuck. On number 7. No. Wait, no. I got to 9.5. I was stuck on number 1. So I feel like I'm being lied to by the documentation for stat summary. So the question is, what is the default geom associated with stat summary? In the documentation, stat summary, geom equals point range. So point range would be the default. But that means there should be a way to use point range to create the same plot as this thing right here. And let's go and actually try to do that again. Wait, that's not the right window. That is. So first we need to get tidyverse in here. And this is the plot that we're given, and we need to rewrite it to use geom point range, allegedly. So we're going to give it an aesthetic. X is going to be cut. Y is going to be depth. But we need to give it like a Y min and a Y max argument that I don't quite understand. Or an X min and an X max, I guess. But like X is a categorical variable, so I don't know what a min or max for that would be. Do I know? Wait, should I be doing it like that? Like fair versus ideal? I don't know. This is probably going to give me an error. Okay, well, let's actually, that's actually not as far off as I thought it'd be, to be fair. Um, this is what I was trying yesterday, and it gives you a bunch of dots, which is not what I want. Maybe isn't can I just naively say min of depth and max of depth? Let's find out. Let's be naive. Oh my! I hate how most programs do smart parentheses. Okay, that's progress. That's closer to what we want. Zach, thank you very much. Oh, nice, Fembox. I appreciate it, Zach. I hope your stream was good. I was lurking. Um, as soon as that last PDE question came up with the predator prey system, I was like about to start typing, like, man, I gotta get set up to like go live. That was a cool question though. Um, yeah. The quest to learn R continues. That's what I'm working on today. I'm trying to make this plot be not stupid. Is the current task. Got to keep me motivated. Yeah. Well, yeah. I mean, what I wanted to do with that, with the question you're looking at from the Wikipedia was rewrite. I wanted to use the product rule for divergence to rewrite that last term in the first equation, but I didn't actually do it. So yeah. Uh, the book that I'm working with wants me to replicate this plot here, which is nice and clean. Instead of using stat summary, though, it wants me to use geom point range, and I'm trying to figure out how to use geom point range to actually do this. Yeah, I imagine it'll be easier to interpret if you do that, having seen what it actually looks like. Okay, so actually, wait, no, I don't want to geom point range. So the thing I'm messing up is y min and y max. I think line end equals but. Okay. Um. Uh. Trying to find. Yeah, I guess let's click on y min. Position of annotations and to represent rectangular areas. That doesn't help me at all. Just got back from lunch. A few friends and I were basically talking about math and physics for 2 hours in an Indian restaurant. Ooh, cool. I did see you and Slim doing number theory. Hey, Slayer Darth. It's going good. How about you? They're doing... So what is fit? It's just one of the columns from the diamonds data set, which happens to be the same one that I'm trying to do something with. What is se.fit? Or maybe fit is supplied from the prediction. Yeah, it is. Trying to like some rudimentary math textbooks you can teach yourself from scratch again. Ooh, cool, cool. Yeah, I mean, my default recommendation for that is OpenStack. It sounds like you have your own thing going on, but if you want something that's just kind of like, it has all the basic stuff. Wait, what? Discord updated? Okay. I need to update my math resource page. OpenStacks. So in case you didn't already know about it, they have textbooks for pretty much everything you can want for like the most fundamental math up through like calculus, all like free. Hmm. Let me look back at textbook. Actually, geom point range. Also, I really hate the titles for this documentation. Like, get the title should be the name of the functions that you're talking about. Ugh. This is the same documentation that we were just looking at inside of our studio, but it's way easier to have it in the browser. Fatten. Wyman equals lower. Yeah, I really don't understand what it means. Like, why does this produce this? I have no clue. TRT resp. Can we find a relationship? So Wyman is lower. The first lower is 0.8. That could be about 0.8. The next one is 4.6. That looks like 4.6. Oh, okay, maybe we're piecing it together. The next one is 2.4. That looks like 2. Really? What is this plot actually telling you then? Like, the y-axis is resp, and it's 1534. I feel like this plot says nothing about resp. Well, okay. Or is this like manually coded in? So in the for TRT we have two things in one. It's 1 and 5. 2 and 2 is 3 and 4. This feels like it's hard-coded in. Like... Spread? It's a rest. What else is there? Like, there's no particular reason why these bars should be this size based on just these two things here. Let's get another one. Wait, what is P? P is ggplot. Okay. What's the difference between... Oh, that's line range, so I shouldn't even... I still don't know what... Like, this plot seems entirely useless, but we are more interested in point range anyway. Which is the same thing. Just points in the middle, apparently, to show the median, I would guess. So I'm even more confused. Why what I said didn't work? Like, I feel like this is perfect. But it's not. What? Ooh, wait. What if I delete y equals depth? Would you be happy then? No, you would not be happy then. Hmm. Oh, wait. These all have the same min and max. That's a problem. Response? Maybe, yeah, I have no clue what that data means. I need to group this by cut. That's a problem. Or that's something that I need to do for the y-mins and y-maxes. I don't think it's going to solve the entire problem, but it'll solve part of it. Papadoria. Apparently there's a convergence test that states the infinite sum of a sub n converges if f sub 0 equals f prime 0 equals 0, where f of 1 over n equals a sub n. What? I have never heard of that test. I'm trying to learn R, Papadoria, and I'm currently struggling with a R with tidyverse, and I'm currently struggling with ggplot. It's not quite doing what I want to do. I'm trying to figure it out. I'm gonna look at what Zach sent, and then I want to write out the tests that you put in chat there, Papadoria. Yeah, doing something like shape or color equals... Oh yeah, factor! Maybe we want factor. Hey, famished. Really? Okay, thanks a lot. I think it's something like that, Zach. Oh, congrats on the first. Okay, anyway, let me write out what Papadoria put, because that seems kind of wild if that's actually a real test for convergence. So, uh, the infinite sum of A sub n. This song sounds familiar. Oh, this is the, no, it's not. Never mind, I haven't heard of this song. I was about to say Lorne Anvil, but it's not. It sounded so much like that, though. This is a completely different person. It's Placeholder for the Night by R. Missing? Okay, so Papadoria says the infinite sum converges if f of 0 is equal to f prime 0 is equal to 0, where f of 1 over n is equal to a sub n. What the heck is this saying? It is like that. Yeah, like the song. Oh, we do have a Minesweeper in queue. And hey, Jed, you're going to do the dishes or will you change your major to biology? What? Is that like a lab joke? We have to like clean test tubes or whatever? I don't know. You have to do that in biology too, though. You condemn the color blue, famished. Yeah, it's a free country. Do a Minesweeper. We will. You'll never be last in line. You will always excel. Okay. Draw a large square and a small square and make a 3D box. that sounds like a drawing I can handle, famished. Small square? Large square. Well, I guess the perspective is going to be bad if I do it like that. Something like that? Used to draw those growing up? Same in general chat too? Okay, yeah, I do want to unpack this and see what it's actually saying. Let me do the Minesweeper though. Um, because like that series thing is really weird to me. Because if f of 1 over n is 0, then the series, it starts from some really big number. Fuck! I just wasn't paying attention. I should stop trying to do math in my head while doing Minesweepers. I kind of jump scared myself when I clicked on that mine. Okay. 35 seconds? Not bad. We do need a peppy voice saying that, Zach, yeah. Our teacher will guide us through a tower? Okay, nice. My best deep voice? Do a Minesweeper. That's not how peppy sounds, though. Can't unpack an illustration of a box? That's true, Jed. You need to require the second derivative exists. Okay, what are we doing here? So let's draw a convergent series. Let's say it's nice and monotonically decreasing. The 1 over n, wait, f of 1 over n equals, what does this mean? Ooh, wait. Oh, okay. So I was getting confused about what this actually means. So if you have f of 1 over n, I think you're actually like, it's almost like you're reversing the order horizontally. I thought it was gonna be more of a vertical thing. But, hey, Sage. Um, but I think, yeah, okay, this actually makes perfect sense now why this would mean convergence. Because we're basically gonna mirror this going off to the right instead now. Oh, yeah, true. I guess this would be compressed between 0 and 1. Actually, wait, I can be lazy. 1. There we go. Much simpler. We have guests coming for a barbecue. A lot of them. Ooh, that sounds fun. It sounds delicious, too. Enjoy, Sage. Um, so yeah, this is a clever way of talking about the tail end of a series. And I think the exact same thing works for a sequence too. Like, there's nothing particularly special about being a series. Um, but yeah, so f of 0 corresponds with the tail end of the series. And so if the tail end of the series flattens out, which is what this is saying, you have a convergent series. And actually, like, couldn't you relax this requirement? I think you could say, like, does f of 0 have to equal 0? Couldn't you throw that away? Oh wait, maybe for absolute convergence. Never mind. Absolute convergence, you probably do want you probably need 0. Edit fractions can have a factorial. Basically, like the gamma function. There's a way that you can do it without talking about gamma function. Um, well, oh wait, I'm thinking of combinations. Oh, you want the interpretation? It's a good question. I don't know if there's an interpretation. Let's Google it. Interpretation or factorial of fraction. See what the good people of Reddit have to say about this. ELI 5. What? That can't be right. Hey, Razor, welcome in. I don't know if there's an interpretation, to be honest. Like, I think you probably lose the combinatorial interpretation when you start talking about fractions. I'm American from California. I don't know why Wikipedia isn't loading. Oh my god. Okay, yeah, I'm sorry. Wikipedia doesn't want to load, and I've lost my patience, but I can't think of an interpretation for it. Yeah, that's a good question too, Papadoria. If the second derivative does not exist, what does that mean? Like, what does it mean to be... Because we know that f prime of 0 is 0, but if f double prime was infinite, what does that mean for the graph of the function? Oh, well, Razor, double welcome. There's a small but mighty niche of us here on Twitch who do this. So I was just rated by Itsutsuai Pai, who was just here in chat. But this is a list of people who I kind of like generically can recommend for mass streams, and there's even more people than just this. The people who are streaming are also like Academy of Ideas. Is possibly streaming tomorrow. Actual Education, Ian Stuckey, Itsutsuai Pai, Ensabux Pachinko, and Penn Center are the ones who have been the most active recently. Also, Suna, OW. But yeah, so none of our channels are very big, but it's a really cool niche with a lot of cool people in it. So, like, I really encourage you to just like look at a bunch of people's streams and see, and just see who you like jive with, I guess. Yeah, feel free to like share what your background and what your interests are if you want. I have a master's in applied math is my like background. And this question is from Papadoria in chat or in the YouTube chat. What is it? Okay, so if the second order function blows up, what does that mean for the original function? There's at least 4 that That was my answer before. That's my answer now, Leo. For gore. Because yeah, that requirement kind of stuck out to me too. For the second derivative. Cause it like I feel like. Okay, wait. So no concavity is just a flat line or like a diagonal line. This is some concavity. So would infinite concavity be like really narrow, I guess? Okay, wait. Let's name a function. Can we name an example of a function that meets these requirements and the second derivative does not exist? Um, Papadoria posted this theorem or test or whatever, Leo, and we're just trying to figure out at least a sort of proof for it. Like we don't need to like formally prove it, but we're just trying to understand like why is this requirement here for the second derivative, and like how might you prove it? Yeah, Slayer, I've been thinking about cleaning that list. I feel bad taking people's names off, which is why I don't. But there's definitely a few people on that list who haven't streamed it in a while. And so I probably will take them off at some point, and I'll put them back on if they do stream again. But yeah, like Talos, as far as I know, is like living his best life at university. Meriwether, I haven't heard from. I'm not sure. And Rand, I've seen him streaming semi recently, but not that recently. I'm not sure what he's up to these days. Did he, Leo? I'm French, basically in my first year of a program called MPSI. You can ask ChatGPT the AI what that is. It's a bit hard to explain. The French system to an American, extremely demanding track. Okay. Well, good luck with that, Razor. I'm trying to think if there's any French language streams that I know of. No one who streams frequently, unfortunately. Math, physics, and engineering sciences. First year program CPG specific, focus on math and physics with some engineering. Ooh. Yeah, it sounds difficult. Yeah, Papadoria. I guess so. If the double prime blows up, we can find a neighborhood where it's getting arbitrarily large. So I think you're right, Papadoria. Oh, that's clever, Slayer. Oh yeah, Femlux, feel free to drop their name. Oh, okay, no worries. Is it Kuift? I just remember. Yeah, I think it's Kuift from Quebec. Oh, okay. But Kwift might also speak French, though. Let me see. I remember recently seeing someone from Quebec. I don't know. I might be getting mixed up. So that country's ISO Alpha 2 code. Yeah, it probably does, Slayer. Yeah, and it's sorry. I'm happy to do like any level of math, but I just kind of go with what people are asking me. Professor of 12th standard showed it to me. Looking through my notes, never written motivation/proof. Okay. everyusa.com. Yeah. Um. Yeah, it's kind of funny. I haven't seen a requirement like this that I can think of for other theorems, but I guess I can see maybe why it's there. But I think your instinct is right, Papadoria, that it has to do with being able to bound f around 0. I think of other less well-known convergence tests, yeah. Like this bad boy is one of the lesser known ones. Wire stress M test. And there's one that has to do with logs too. I can't remember the name of it though. Series convergence log test. Let me see if this is enough to bring it up. So maybe the Dirichlet test. Cauchy condensation test. That's a fun name. Ooh, A sub 2 to the n? Okay, I think this is your Wikipedia page. Papadoria. This one is kind of fun. Looking at powers of 2. That's probably a good one if there's a log involved. Abel says, I've heard of this one too. Oh, yeah. Okay, Dirichlet has something else, I think, that I wasn't thinking of. Abu... Oh, hey, okay. Interesting. Commerce test? Ugh. And I'll catch up with what you're saying in a second. Yeah, it looks fun. Gauss's test. Ooh, asymptotic. Yeah. I guess that's like finding a... Well, yeah. Yeah, that's it. You need something else to make that work. Where is it? Converge if and only if. Negative non-increasing sequence. I guess the non-increasing part is what makes this work. Because you could engineer a sequence that's well behaved for powers of 2 and not well behaved otherwise. But I think the non-increasing saves it. Does if and wave have its own Wikipedia page? Oh yeah, it does. Okay, let's see what Leo typed. F of 0 equals 0 implies a sub n. Okay, yeah. A sub n goes to 0 as n to infinity. I agree with that. F prime 0 is 0 implies a sub n is little o 1 over n. I can imagine that's probably true. And Leo's thinking about considering f of 1 over n minus 1 over n log n? I'm not sure what that would do for us. Do non-increasing subsequence. Ooh, yeah, maybe you could Papadoria for generalizing it to other subsequences. The best series convergence test is Cauchy's. I scrolled past it. Cauchy's convergence. Is oh yeah, okay, that makes sense. For right would be something like that. I don't know how you would use that, but I can go with that, Razor. Chemistry? I'm really not good with chemistry. You can try posting it, and maybe someone will know the answer, but I probably can't. X over log x 1.5 may already be a counterexample. Second derivative of 0 doesn't exist, but the sequence converges. Senior sequence is O 1 over n squared. F of 0 and f prime. Oh, you mean in this example? Okay, yeah. Yeah, I was still trying to unpack why this is true. I assume it is a Taylor series thing, and same with f double prime. Hey, Skirt. You will have gold pieces by the bushel. Ooh. Multiple bushels of gold pieces. Oh, yeah, that makes perfect sense, Leo, because the Taylor series, of course, it means that f of x can be written as like 0 plus 0x plus some finite number x squared plus ox cubed. Okay, yeah. And of course, if you make x equal to 1 over n, you get the thing that Leo's saying exactly. Yeah, right. So we need to like flip your functions or something. Well, then the log would break. I don't know. What about n over log n? That would exist at... No, it wouldn't. the limit would exist. Would it? I don't know. It is, yeah. Like, the limit existing might be okay, though, Leo, because, like, f of 0, it is the tail end as n goes to infinity. So I wonder if we could still sell something with being okay with just the limit existing, even if f of 0 itself doesn't exist. But then this statement isn't quite accurate. So maybe that's not right still. Um... Yeah, like a one-sided limit will be fine with what I was saying. I don't know if what I'm saying overall is fine, but hmm. Oh, wait. I was thinking, I said before that there's nothing special about a sub n being a series here, but there actually is something special. This is just a sub n. That's actually a really big difference. My drawing here is misleading. So this is more like a p-series idea, I think. And Leo, I think what you said, yeah, okay, so for a p-series, you need to require alpha is more than 1 for it to converge. And I think what this stuff right here tells you is that a sub n could be written as some constant over n squared plus big O 1 over n cubed. And you can do a p-series on this bad boy and a comparison on this bad boy, and you would have convergence. I feel like that's all there really is to it. Let's say those series in the generalization. Some 1 over n log n does not converge. 1 over n log n to the alpha for alpha greater than 1 converges. That makes sense. You can do a comparison, right? I think a comparison works. Engineering a series that converges slower than 1 over n squared, turning into a function with x equals 1 over n. Okay. Okay, I think we figured it out. I think. I was like going back through what I said, and I think we've gotten the important idea. Yeah, there are some weird ones, and like um, you won't you out in the wild, you pretty much only ever need the ratio test too. Is the funniest part. Like I bet all these vague ones were invented because there's like maybe a handful of series that they apply to that we couldn't figure out with normal tests. At best, a handful of series. Okay, that's an interesting one though, Papadoria. Thank you for sharing it. Can I prove sum 1 over p diverges? I can. The integral test is the easiest way. Oh, oh. Can I? Let's think about it. Log n. Ooh. Yeah, I think I need to know some fact about primes that I don't know offhand. Like it like I assume there's some asymptotics for how they're spaced out or something. Hmm. Oh, yeah, I don't know what product decomposition for the zeta function is. Oh my god, Papadoria. I don't know. And I would bet it does. I would think that stuffing more stuff inside of the log isn't going to help you. That's my gut. The prime counting function. N over log n? So we want a bound from below. So if the smallest prime number is 2, we could bound it below by 2 times pi of n. And n over log n is certainly going to diverge. That would be my idea. I mean, I don't know how precise that is, though. We would need to, like, that's probably not precise. Well, that's a funky looking thing. Wait, isn't this really bad? Wait, so why are the ratios converging but not the differences? That's weird. If you try to get a much more precise estimate, you end up getting at the Riemann hypothesis. So if you could show that, that would be great. I don't know why some people get a delay on YouTube, Papadoria. It's weird. Okay, so what's the prime factorization? Let's just look at the page for zeta function. I assume it'll be on there. Wait, is this? No, this is still not the Lorne song. Okay, this is the Riemann zeta function for a complex number S. What am I? Oh yeah. Wait. Prime. Well, okay. Factor is. That looks terrible. Oh, I mean, is this what I actually want? A Hadamard product? Is it in Gen Chat? Okay. Yeah, you know what, Papadoria? Just casually show that little fact, being the Riemann hypothesis, reminds me of your professor giving you the Collatz conjecture in disguise. Yeah, no, I'm never forgetting that either. I guess I lucked out because the professor that I just had for PDEs, he admitted that he's assigned open problems to his students as homework without telling them, just to see if someone would end up solving it. And once I heard that, I was so sure he was going to do that to us too. Thankfully, he didn't. Um, but yeah. Hey Rex, all the effort you're making will ultimately pay off. That's a good fortune. Lady Luck will soon visit you. That's a good one too. Yeah, yeah. What if Lady Luck is coming to take your luck though? Unlucky. Yeah, that probably said he said something about like the holder inequality in a certain context. I can't remember. Um. Okay, so why is this helpful? What kind of lady would do that? Depends on the lady, I guess. Uh, didn't that one guy in some stats class do that? His professor put an unsolved stats problem. The guy thought it was homework. Oh, yeah. I do think it's actually worked for something like that. Yeah. Trick with the right hand side using the fact that the LHS diverges at s equals 1. Oh, that is okay. Yeah, because they said the real part has to be more than 1 for it to converge, right? So we can start with the fact that goes to infinity, right? George Danzig, graduate student at UC Berkeley. That sounds like Berkeley. Arriving late to a stats class, mistake 2 unsolved problems written in the blackboard for homework, solved them, handed them in late. Right, right. Um, wait, why do we want the product? Can't we just go... can we just, if we're able to use the fact that it diverges for s equals 1, can't we just use the sum? Oh wait, no, never mind, that doesn't have primes. Alright, see you, Leo. The analytic continuous something like a -1/12 somewhere. Oh god. Do I have this? Then after that, show sum 1 over p goes to infinity for primes congruent to a mod n for any a co-prime to n using similar argument in Dirichlet characters? Thank you for thinking I can do that. No, I can't do that. I do not have this. It's fine though. I might just go back to doing R stuff. Hey Floppy. I guess I've been tricked into it. I don't know. We started just by talking about vague and kind of fun tests for convergence of a series. And then Leo lectures, I think half jokingly, asks if I can prove that the sum of 1 over prime numbers diverges. And apparently the way you do that is with Riemann zeta function. Essentially, the prime factorization argument is just saying that multiplying by some clever version of the prime reciprocals diverges as all numbers have a unique prime factorization. That's weird. Huh. I think Euler cracked it. Euler would crack it. Sum of reciprocals of primes. Oh, it has a Wikipedia page. Divergence of the sum of the reciprocals of the primes of the. Quadratic equations. There's no question that's too easy. Please, feel free to ask it. They call me. Everyone just needs to prove the hypothesis already. I'm getting pissed off. Same. What a prick. Oh yeah, okay. Fenbox, looks like you're right. Euler's proof. Take the natural log of each side. Use Taylor expansion for log x. Sum of a converging series. Oh, because it's ln of 1 plus. Really? Wait, what? How do we go from every natural number to every prime? But yeah, they call me El Kukwait. As soon as you post it, I'm happy to work on your question. What's up, not Chris? Um, Big Dog Solar was not interested. Damn, that is bad news. What is this though? You're a joke. Oh my god. Damn. How rude of them. You won't give up? I'm proud of you. That's perseverance. I just want to understand this first step. Oh, okay, let's see what they don't Papadoria? Oh my god. I missed that. I was so confused about how the series would do that for you. Okay. That makes a lot more sense, Papadoria. Thank you. Okay, wait, what is this question? Is that the golden ratio? A sub n equals A alpha inverse powered n plus b. What? Or is it like this? Find A15. I have no clue what this question is. Oh, wait, A sub 15. Yeah, I don't know why you think this would be easy. This is not an easy question. Uh, or like, yeah, or like, sorry, like you said it'd be easy for me. This is not easy for me. So I'm confused. We don't know what A and B are, so whatever answer we get will be in terms of A and B. But I'm even more confused because why aren't we just plugging in n equals 15? And that's just the answer right there. Okay, so this is the golden ratio, alpha and beta. So I don't think there's anything else for us to do with this question aside from what I'm writing right here. Like, I feel like I'm missing something here. But this is kind of the best that we can possibly do without more information. So yeah, let me know if I am missing something. They call me El Kukoi, but uh, yeah, I don't know what else you can do with this quote question. Okay, so yeah, I'm sorry, but I'm just gonna move on unless you can be unless there's something more to like do here. Leo lectures, I was only cheating for a minute. I ended up just looking up the article or like the Wikipedia page on this. What relativity bit at lunch? What the difference between point space time was time like or space like? Oh yeah, I still have a hard time being comfortable with space like separation. The motivation for the Euler product thing in Gen Chat. Oh. Oh, that's how you get a sum of primes. Okay. I see it. Sounds good, Leo. Huh. This is a proof for there being infinitely many primes. That's simpler than I would have thought. This battle damage formula? For Pokemon? Middle? This looks complicated? Is this what you mean? Yeah, there's a lot going on here. This is one of those formulas that if you build up yourself, it's probably pretty understandable. But just looking at the end result is super crazy. Oh yeah, there's straight up just randomness in there beyond the other bits of randomness too. That's funny. Multi-turn status effects. Oh, like poison and all that. Yeah. Um, you do that for all primes, you get this. Yeah, I can get behind that. What is that squiggly? It's Greek letter capital Zeta. It's really hard to draw. Or wait, no, I think it's lowercase zeta. Um, yeah, thank you, Fluffy. Uh, it stands for the Riemann zeta function. Uh, so yeah, it has a Wikipedia page. It's as far as math functions go, this is a really famous one because there's a problem involving the Riemann zeta function. Uh, that if you solve it, you win $1 million. So people are really interested in, and also for its own sake, they're interested in learning about this formula. Oh, Kasai? I don't know which one is harder. No one has solved it, not Chris. That so it's one of the Millennium Prize problems. Only one, there's originally 7 of them, and one of them has been solved. So the Poincare conjecture, I guess, is a solved one. Um, but the unsolved ones are all down here. And this is the Riemann hypothesis. So it's a hypothesis involving the Riemann zeta function. Sometimes math is easy, usually it's not. Why aren't they solved fundamentally? Because as far as we found, existing math isn't helpful in solving the problem. And so someone needs to invent some new type of math that can solve it. And that's incredibly difficult because it's so, it's a very open-ended thing to just invent new math. Like, and that's what math research is, inventing new math. But like, theoretically, anything at all could be helpful, but most things probably aren't. But you don't know like what is helpful until you try it. Fibonacci-Tarski paradox was proven, makes you question life too much. It is a weird one. You don't. I think I've had a lot more practice drawing Kasai, so I have an easier time drawing it compared to Zeta. Zeta just feels so like loose. Like, yeah, I don't know. It looks a little bit like Kasai too. Is the question valid? Probably, yeah. If you can find some counterexample, they would take that too, I'm sure. It's probably a valid question though, like well defined. What would it solve? Uh, I probably doesn't have a direct application to some real world problem. It might, but not that I know of. Um, the reason people are interested in like conjectures like this though is that by answering it, we're going to have some interesting new thing. Like we're more interested in the technique to solve a problem like this than in the actual answer often. And so whoever does solve this, if someone does solve it, um, is like whatever technique they use is probably going to be helpful in other problems too. And I guess, yeah, if you're interested in M prime numbers, there's applications there. Which I guess that could be useful for cryptography. When I drew it just like a squiggly line with no purpose, that's how mine feel too. Totally not Colette's conjecture question for you. It's totally not an open problem. We didn't do it like 2 years ago. uh, it, so it's not like we're not looking for a number. We're looking for a proof. The conjecture itself is that the answer is 1/2. We are Papadoria's bearing problems. Yeah. So, there is, well, it's what we think is true. So there's, and we can verify that it's probably true by using approximations. Yeah, exactly, hypothesis. But approximations aren't proofs. So we can always use computers to like plug things in and get approximations, but we want like a classical math proof. And there actually is a coding language for math proof called Lean. And so theoretically computers could try writing Lean code that would solve this problem. That's kind of different to what you were saying though. Since pi is infinite, I mean, it does have a proof. I think a definition is a better word than proof. But even though it's infinite, there's ways in math to still define it properly, and it makes sense. I mean, some people claim that it doesn't make sense to have infinite numbers at all, but we're ignoring those people because that's like a fringe thing. Or at least fringe is too extreme, but like it's not like the mainstream. Riemann theorem once proven. It'd probably be like Riemann hyphen the name of whoever proves it theorem, I would guess. And so 3.14, or like 3.14 going on forever but not repeating. That's the entire thing about pi. It has no pattern, but it does go on forever. So the word repeating is a little bit iffy, but it's the right idea. I never thought about that. It'd be really inefficient, but you could. Yeah, for sure. It would only get you, there's only 10 options for like types of randoms that it could generate, but maybe that might be enough for your application. Yeah, it's pretty expensive to compute digits of pi after a certain point. But we have ways of doing that. The Mordell-Lang conjecture got named Falting's theorem. Oh yeah, I haven't heard of that, Floppy. So yeah, I would hope that whoever proves it would get credit. Definition-wise, yes, it is properly defined up to most people. Like the fact it has infinite digits to the right means that deciding whether pi to the pi is an integer, rational or irrational, yeah, is hard. How do you reference an index in the millions via notation? Well, let's look at the Wikipedia page for pi. I think that'll yeah, it's like storing that many digits in code is pretty terrible. You could throw away the earlier ones when you don't need them anymore. Well, you kind of do. The Modern Quest for More Digits. This is very like a poetic title. Ooh, this is fun. This is how many digits of pi we have approximations for, dating back to 2000 BC. And so this is a logarithmic scale here too. So this like this growth is really fast. Or like over here it's really fast anyway. That's cool. Um and yeah, computers were right around 1950. Back then we were bisecting regular n-gons. People dedicate like 600 years to get barely 100 digits. Not yeah, we didn't have 100 digits until 1700s apparently. But I feel like that feel I wonder if some data is missing. Because I thought there's a Chinese mathematician who had a really good approximation for pi early on. I don't remember how many digits though. Babylonians 25 over 8? Bleh. The Egyptians at least knew about 22 over 7. Or did I think I said that wrong. No, 22 over 7 is right. Pyramidologists? Oh, there's an Indian mathematician. Oh, that's okay, that's I'm not a fan of this. I swear there's a Chinese mathematician who had a good one. I think it was after yeah, okay, here. How many digits? Oh, I guess not. 265 AD. This is yeah, Zhu Chongzi. This is the person who I was thinking of. So it's not as early as I thought. 480 AD. First only for 7 decimal digits for the next 800 years. So wait, okay, 480 AD. Where was that thing? 480 AD. Oh, look at that jump in years from 480 to 1400. This scale is all over the place. They really compressed the ancient history, which makes sense because like there were progress was pretty incremental back then. Around 1500, Kerala school recorded using Katapayati number system. Wow. Bicycling Angons was very inefficient. Yeah. Hyperplane separation theorem. I've talked about this maybe with you or someone else somewhat recently. Okay, yeah. This is one of those things probably deceptively difficult to prove. It's like it makes intuitive sense, but actually doing it is another thing, I would imagine. Here, I'll stand on the thing up here, Papadori, so you can read it. Not the functional analysis? Is this a functional analysis thing? I would just call this like geometry, I guess. Yeah, the Jordan curve theorem. Yeah. It probably does come up in functional analysis, though. Yeah, that would be. I would believe it, Echo. I had some geometry stuff like this come up in my PDEs class. Like we talked a lot about convex sets. In some textbooks, the proof is something like the proof is left as a trivial exercise to the reader, probably. The implementation in JavaScript? Ooh, cool. Hambanak. Oh yeah, I saw this in the generalization. Oh, hey, yeah, that's in functional analysis. That makes sense. I only know some of these words, but what I'm gleaning from this kind of makes sense why it would have something to do with the hyperplane separation theorem. I can try Flofi. Like I personally love differential equations. Where are you at in your studies of them? Or like, have you taken a class yet, or you use it in a JS project? Okay. Function analysis is too cool. I know almost nothing about it. It's something that it's on the bucket list for things that I want to study. Probably won't happen anytime soon though. Collision detection. Oh, nice, nice. Yeah, that's exactly when you'd want to use this. Advancing it on its integrating factor. Okay, so it sounds like you're early on. Okay. How to not be afraid of differential equations. What to say, what to say. Okay, the first thing is that most introductory differential equations classes kinda suck. And it's unfortunate, but it's the truth. It reminds me a lot of like a second semester calculus class where they teach you advanced techniques for integration. That's just a bunch of memorizing tricks. And unfortunately, that's what introductory ordinary differential equations also is. It's just memorizing tricks. ODEs are nice in a way because these tricks even exist in the first place and we can just get an actual solution to a lot of ODEs. Once you start seeing real ODEs and PDEs that are actually representing more applied situations, they tend to stop having easy to get solutions pretty quickly. Or maybe the solutions are just like too complicated to be helpful. But yeah, fundamentally, a lot of ideas in differential equations come down to taking advantage of if y of x is e to the x, then this function is magical and it has a really important property that y prime is equal to y. And so whenever you have a differential equation, it really is echo, and that's what I'm getting at right here. So whenever you have an equation that relates y to its own derivative, it's not guaranteed, but like if you have something like y prime plus 2y equals 0, your mind should immediately go to something involving e here. Because of it looks kind of like that. Just instead of y prime minus y equals 0, it's a plus 2 there instead. But still, like, we can do some magic with e in order to solve that. And the same thing goes, you'll eventually get to second order ODEs, which is something like y prime plus 5y prime minus 3y equals 0. And the same idea applies here. Like, this property here also implies y double prime equals y prime, but that equals y. So even when you encounter something with two derivatives, you can still think of e to the x as being involved. Do I know of any course that specializes in functional equations? It's the least talked about form of equation. No, it feels like more of a competition thing, because I don't know when they really get applied often. We could do a Google search after this. See, I don't know if this is making you less deathly afraid, but exponential functions e are your friend. And after that, it just like, and yeah, so like Laplace transforms are a thing too. Aside from that, like there isn't much of a general way to solve differential equations. I'm ignoring Laplace and Fourier transforms, which are the closest thing to a general technique we have, but they don't work in every situation. Or they don't always give you things that are easy to work with either. What I'm afraid of is it's just about being intelligent and memorizing tricks. You're dumb, so you need to systematize things to solve problems. I mean, I don't think that's a dumb thing. Like a smart or stupid thing. I'm not gonna lie to you though, it is memorizing tricks, and that's just the way it's taught. It doesn't have to be like that, but it is like that. And that's just the reality of most university introductory DE courses. It the things you're going to learn are going to come down to rewriting differential equations in ways that are familiar to us. Because of what I said, where we don't necessarily have a general way to solve ODEs. Not really a good one. So when we have something we don't know how to work with, it's like what you learned with integrating factors, is solving ODEs that maybe look something like that. But we could focus just on the left-hand side and do anything it takes to write it like a product rule, like something y prime is equal to x squared. And then you could integrate each side. Just like an underscore there to say that there's something there. Dx is equal to integral x squared dx. And then fundamental theorem calculus would take care of that. So, and like this thing that is like blank here that I haven't written is the integrating factor. So it's hard for me to say a general like system that you could use for differential equations, but the pattern that'll exist throughout all these tricks is rewriting differential equations in some way that to make it into something that you've seen before, or that like in some like known form that we can actually work with. Turns out we're only gonna be able to harvest half the energy we thought we could because the dark side of the moon, not Chris. Yeah, we didn't think this through. We should have listened to Pink Floyd, literally and figuratively. I have so many Wikipedia pages open right now. Oh my god. Most math things in university cannot be worked out algorithmically. Solving integrals, memorizing tricks, and experience. Yeah, integrals in a similar category. When it is, the tricks tend to be more interesting, generally applicable than the tricks from calc. If the tricks are about understanding the general behavior of differential equations, I'd be into it. Passion math is clear. I think with enough drive, you can forget about worrying if you're smart enough. First person no drive won't reach their goals. Yeah, motivation is more important than natural talent, I would say. I can prove something about group homomorphisms. I can usually try to find something similar. I can prove about group rings or about graphs. Underscore. Oh wait, sorry. I saw that follow and I forgot to acknowledge it. Maiku Senpai, hey, thank you for the follow. We call the Weierstrass M-test convergence normal? Ooh. Is it normal in some way? Is that what that means? As in like common, or I wonder why it's called that. Um Yeah, I'm not sure if like rewriting things as to have to do with product rule is a really common technique in differential equations in general, like including PDEs. Um, maybe let's talk to my friend Paul. I let me talk to my buddy who's an expert on differential equations. um, so what am I trying to say? I don't know what I'm trying to say. I guess usually the emphasis is on like these first three things here, maybe a bit on substitutions. Um, and also about like initial values and boundary conditions and things. And I wish more of the emphasis was on like modeling and interpretation. Equilibriums and Euler's method 2 are good, but usually they focus on the tricks and just like solve this differential equation and not interpret it. So I wish they talked more about the interpretation, and I think it will be more in line with maybe what you might want, but uh, it might just be a little bit rough for you, Floppy, unfortunately. Why won't we call it dominated convergence instead? Oh, is it related to that? I never even thought about that. Is a differential equation finding the difference between two things like a Boolean operation? Um, there is a difference equation. There is such a thing as that, which is exactly what you're saying, I think. Um, a differential equation is related. Oh, no, not like that. Not like union and difference. Um, let me catch up with the rest of chat, and then I'll get more into this. Normal, as in convergence with respect to the L infinity norm. Oh, okay, that makes sense. Be more consistent with general notation. Aeneas says relating to dominated convergence theorem. Okay. And this is called subtraction. uh, intersection is another one. Yeah. Difference equation is what it's called a linear recurrence relation. Yeah. So, um, how should I say this? It's not exactly the same thing? Okay. So I guess what we'll say first, a differential equation is called differential because in calculus, you do something called differentiating a function. And that's what the word differential refers to, a calculus thing. They do have a really nice like physical interpretation though. And that's what I want to try and convey. And it is related to difference equations too. No, it's not like that. I don't know why they call it differentiating. It's not I like I said I do, but it's not so direct as that, unfortunately. Okay, so yeah, Fluffy's saying what the answer is, and I'm trying to build up to that in a way that makes sense. So, okay, let's talk about just like speed and position. So, your speed at a time t I don't know if this is gonna make it more clear or less, but okay, wait, let me not even involve time or like that for a second. Okay, so just in general, speed is distance over time. Delta is a good place to go here. So, okay, yeah, if you know delta, I'll use that. Like, speed is change in position, delta x, over change in time, delta t. So, if I start at we could make it a vector. I'm just kind of keeping things one-dimensional and only going in one direction. We could involve a vector though, but it's going to make the next part a little bit weirder, so I'd rather not. If I start at position 0, this is x. This is me. Let's put a smiley face on there. But my chin is not great. if at time 0, I'm at position 0, and then I run, let's say like 10 meters or feet or whatever forward, in 5 seconds, we could say that my speed is change in position, 10 minus 0, over change in time, 5 minus 0. And so we can simplify that to be 10 over 5, which is 2. And so my speed is 2 for this. Thick beard needs more beard. It does. Hey, Slim. Assume you can run to that place at the same time each time. Yeah, so we don't need to worry about like being too exact here, but yeah, basically, yeah, not Chris. So in this example, my speed is 2. You do always know the start and end, exactly, yes. And so this is like a simple case where I'm running at the same speed for this entire time. But what if I, like, maybe I started slow and then I sped up and then I slowed down again, or like something weird like that. It's no longer good enough to just look at the start and end. We have to look at like when do things change. Exactly, yeah. So we split it up. So let's say like at 3 seconds I change speed, and then again at like 7 seconds I change speed. Yeah, you could average them. We're not going to average them, but you definitely could if you want like one universal number. What I would say instead is like maybe on this interval, like um maybe on this interval I'm going 3 miles an hour. On this interval I'm going 2 miles an hour. Then on this interval I'm going 1 mile an hour or something. Like I start fast and I slow down. Um and so we'll just take this as our answer. Like depending on the time, um our our speed is different. So for different times we have different speeds. Um it's like there's like a function relating these things. So um s is a function of time and delta x is a function of time. And as it turns out, these two things are actually related through calculus. Um and that's what I'm trying to get at here. That's actually like the exact idea that we're like building up to. Um And so the next question is like, so we split up into like 3 pieces, but what if I'm changing my speed all the time? Like, uh, if I'm like, one instant I'm going fast, one instant I'm going slow, if my speed is all over the place, we need to split it up into a bunch of teeny tiny intervals in order to accurately say what our speed is at each time. Um, and the process of doing that for like as tiny of an interval as you can possibly imagine, not quite 0, but nearly 0. Um, that's basically the definition of a derivative. Which is what like differentiating a function is. We're not averaging. Like it's not a bad thing to think of, but this isn't related to averages. You could take the average of all these, but it's not related to this. Yeah, we're dividing this up into a bunch of little teeny tiny intervals, and we're measuring the speed on each of those intervals. So it gives us a relationship between speed and position. So the fact that speed and position have this relationship, that when you break position up into all these tiny little things, you get speed and you divide by time. It means that if x is your position, then your speed we can call x prime of t, and prime means derivative. And this is just kind of a notation thing, but wait, oh shoot. Am I saying this right? Yeah. Okay, yeah. Yes, okay, yeah. An appropriate relationship. Doesn't necessarily have to do with units, but you could think about it in terms of units. Like, if speed is in meters per second, you do want to have a meters on top and a seconds on the bottom here, for sure. And I do want to scroll back up and see what underscore said. Use any differential equations, just equations describe some variables to another. Yeah. And so this is what this is just what a derivative is, or like what it means to differentiate a function. Um, the thing I want to say is, so if you take your position and you differentiate it, which is what we talked about with splitting into teeny tiny intervals, you get speed. A differential equation, and we call that differentiation x prime, where then that prime is just an apostrophe. A differential equation is just some equation that relates a function to its derivative. So like it could be like x prime plus 5x. Sorry, I should be saying of t because this is confusing. And solving an equation like that takes some techniques that you wouldn't have seen yet, but it is possible to solve equations like this. Rate at which water boils in different heat applications over time. I think so, yeah. I'm working on my head if that's actually right, and I'm pretty sure you could. Shoot. Energy, I meant to, and it just, I forgot to, I'm sorry. I still have it in my YouTube history, so I can come back to it. I did not, though. Okay, I want to turn to what underscore was saying. When it comes to ODs at entrance university level, I think it's very important to focus on the more common ones first and ignore the tricks. First order linear, integrating factor and variation of constant method, separable variable, second order linear with constant coefficients, with characteristic equation. Right. I like that. On second level, you go with order n linear, right? Second order linear with a Wronskian. Yeah, that sounds like a better version of ODs to me. It like I would put in more about the applications personally and like interpretation, but like, yeah, that's a good direction to take it to. Six find solutions via series. Oh yeah, for me that's more of a side quest, but that's good to know too. Um, yeah, I'm trying to think of the simpler analog of the heat equation, which is what Papadori is talking about. There is absolutely an equation that tracks the spread of heat, though. Um, and I'm trying to figure out the simple way of explaining that. It's not coming to me right now, though. It might be like a Newton's law of cooling thing, or Newton's law of heating too. Oh, okay, yeah. uh, no worries. Enjoy your food. Oof, okay. I swear, I've explained what a derivative is so many times. I still don't have an explanation that I'm happy with, though. I think this one could have been improved. This one just kind of came to me in the moment, but I'm not entirely happy with it. Yeah, I guess it's back to R unless someone wants to distract me again, which is always welcome. Maiku Senpai, the limit of the slope of the strings. Of what strings? I'm not sure what you're talking about there. Um, oh, okay. You're saying as an explanation for the derivative. Okay, I thought you're asking me something. Oh yeah, yeah, yeah. Oh, okay, okay. Um, yeah, you're talking about like the English term is secant. That's usually what I go with. It just didn't feel right in the moment, I guess. But like, yeah, if you have some function like that and you want the derivative here, you could talk about like, well, I guess like a line like that as like a secant line. And in the limit, as you bring this other point closer, you get your tangent line. Yeah, that's what I usually go with. It just, I don't know, it felt a little bit too mathy, and I wanted to try to make it more intuitive, but I don't know. I think it was not mathy enough. Do you think the infinite subdivision part lended more to integration? Yeah, there's definitely some integration, like because I was keeping like 0 and 10 fixed. It definitely does feel like integration a bit there too. Um, it's still like yeah, that could lead to confusion. I think what I said is right, but it's maybe confusing for that possible reason, or it could be confusing depending on the person. Someone interprets things differently. To go from average speed between 2 points and instantaneous speed. Yeah, that's what I was like trying to do underscore. um okay, so for those who are just joining, I've been trying to this is unless someone asks me a question or wants to talk about something, what I've been doing in the downtime is trying to learn about R, and I've been stuck on this really annoying question, which is basically to recreate this plot here. All right, sounds good, Papadoria. Get some sleep. Thank you for hanging out. Um, yeah, and make this plot, but instead of using stat summary as they did here, use geom point. And I'm getting confused on how to use geom point. It's been my big issue. Or geom point range. My favorite differentiation calc theorem. Well, I don't know what these would be. Differentiation calc theorem. Oh, Rolle's. Okay, no, I see what you're saying now. Like Rolle's theorem or Lagrange theorem or Weierstrass. That's a good question. And like I think like intermediate value theorem too, average value theorem. I think so you said English isn't your first language, and I do think that different languages have different names for these theorems too, which will make it confusing. Uh, what will be my favorite one? My mind is going to intermediate value theorem. So if a function is continuous, it has to attain, at a minimum, every value between f of a and f of b. Oh yeah, no, I know you're not judging. um, and this one came to mind for me because it's fun to apply it in higher dimensions. And I don't necessarily mean these generalizations, because these generalizations are kind of weird. I looked at them before. But you can apply them in higher dimensions a little more simply, where like, if you have a continuous function, let's just say it maps, let's say omega is a subset of R2. You have a function u that maps omega to R, and u is continuous. You can use the intermediate value theorem in this situation if you just kind of take secant lines on your domain omega. It's like whatever the value of the function is at this point here on the boundary, whatever the value function is there, you can use the intermediate value theorem on this like line connecting them, which is kind of cool. As long as like you need to be sure that the line is contained within the set, so you can be in danger with non-convex sets, or like this line here would be a no-go, so you should be careful about that. But other than that, yeah, it's a good one. Maybe niche to non-complex analysis people, you really like Rouché's theorem. Oh yeah, that's a cool one. I was thinking of like first semester real analysis stuff. If we do go more advanced though, this is a good one too. For any two complex valued functions f and g that are holomorphic inside some region K with a closed contour dk, Donkey Kong, if g of z is bounded above by f of z, absolutely, then f and f plus g have the same number of zeros inside K, where you count them according to the multiplicity. Which is kind of crazy. Like, I think the multiplicity part is what makes it really crazy. If you ignore multiplicity, I think it will be pretty, like, clear from this bound here. Because that bound is, like, pointwise. But assuming holomorphic plus this boundedness, I think gives you the multiplicity. Yeah, that's a great call too. Complex analysis in general is just a great thing for beautiful theorems. What is this here? Also, an informal explanation of Rouché's theorem. One popular informal way to summarize this argument is as follows. If a person were to walk a dog on a leash around and around a tree, such that the distance between the person and the tree is always greater than the length of the leash, the person and the dog go around the tree the same number of times. What is this saying? This is the phrase that's confusing me in this explanation. If the person is holding the leash, how is this possibly true? I feel like I'm misinterpreting this sentence, or this part of the sentence. You're kind of unhappy. You want to do math in my spare time. You have to work so much for my university. I don't really want to work on math in my free time anymore. Yeah, Echo, I had that exact same issue. So I just recently completed a master's in applied math. And it was a really intense program, and it kind of like burnt me out. And so definitely while I was working on it, I was not too interested in doing math that was outside of my coursework, which is kind of a shame. Comes from the argument principle. Right. Yeah, I remember like logarithms are like the fact that their branch cut works like that has so many implications for things that are actually kind of nice. Because the branch cut, it just looks wild and annoying to work with. But the fact that it has that does a lot of good too. Like counting the multiplicity for roots and stuff. Or that's just called the winding number. Your brain's RAM is occupied. Yeah, I like explaining brains in terms of computers too. Yeah, I hope that you get to take classes that are more in line with what you like than Echo. But yeah, there's always some classes you have to like get through them. You can't decrease some work. I mean, usually that's pretty difficult to do in university. What type of degree are you working on, Echo? You're already not taking the maximum amount of courses? Okay. Yeah, then I imagine doing a math bachelor's. Ooh, nice, nice. Yeah, I regret it now, but when I was doing my bachelor's in applied math also, I kind of intentionally avoided the difficult classes that would have had that effect on me. um, you're doing functional analysis at the bachelor's level? Jeez. That's ridiculous. Yeah, functional analysis is really intense. I always thought of it as more of like a grad level thing. That's kind of crazy you're doing it for undergrad. And it's something the professor is the type of professor who should be teaching grad level classes too. It's mandatory. Wow. That's intense. Functional analysis is like I think it's one of the most difficult types of math that you can do. Not knowing I never actually studied it for myself, but like whenever I've had to get like a taste of it from whatever I am learning about. Dysfunctional analysis? Is that real? Or is that a joke? Oh, this is like psychology stuff. Okay, okay. Never mind. It is a joke. Okay. There are some. I thought it might be real because, like, there are some really weird niches in math with kind of funny names like that. MIU, which is an analysis driven university, did functional analysis at year one of a master's degree. That's more understandable. Um, I can see that maybe at the end of year one when you do like measure theory first. Yeah, that's yeah, measure theory last winter. Dang. Like if you are planning to do grad school, it will be really good to know functional analysis already. But I'm sure that class is really difficult, and it will make me also not want to do math outside of my coursework. You're in Germany. Ooh, cool, cool. Yeah, okay, that's also true. Like that makes sense because America is like a lot more we emphasize different parts of math than Europe does. Europe tends to be a lot more like analysis Like I just feel like a lot more like pure math, like analysis, abstract algebra, that that type of stuff. And you can get that in America, but the default is usually like a little more applied. Um, is that university known for being intense? Underscore? Hmm. I think I need to do something with the aesthetic. Uh, I doubt this is gonna work. Let's just. I want to see what it does though. David Hilbert level teaching. This in the late 1800s to early 1900s. Hmm. That makes sense. What are you working your probability theory homework now? Oh, hey, that's good news. So this did not do what I wanted it to do in the plot. Yeah, I guess I should shut them out again, but in case anyone is new to like a math stream on Twitch, this is the list of people who I can like generically recommend who stream math with some frequency. I do need to kind of clean out the list at some point because some people have become inactive, but it's like a good list to like get started with in case anyone here is like new. Pretty burnt out right before my exams. He prevents me from getting back into it. Oh god, when it's hot out, and I know that Europe's having that crazy like heat wave. Um, when it's hot out, I just shut down too. I can't think. I'm really thankful right now that where I am, it's actually rainy, and it's currently 65 degrees Fahrenheit, which is kind of perfect. Earlier in the week, it was getting into like the 80s, and I wasn't happy about it, but it's pretty nice right now. Experienced 8 or 9 years ago. Yeah, like it's just not meant to be that hot over there. So that makes the heat even worse because and like AC isn't super common because you just don't usually need it. I spent most of my life in California where like over 100 degrees Fahrenheit usually have a couple of days like that each year. But like there's a lot of ways to deal with it because it is common like that. Couldn't even get milk today. Most stores closed or tape their cooling shelves shut because the cooling system failed. Wow. Public transport canceled too. 2 minute walk to the store and back up with a mild radiation. Jeez. That's crazy that the cooling shelves shut down. Maku Senpai, good night. Thank you for hanging out. See you later. It's cringe. Uh, I'm really sick of thinking about this problem. Maybe let's move on to number 2. I'm really annoyed why this isn't working how I wanted to. What does GM call do? Sounds good. Underscore. Sleep well. So GM call versus GM bar. GM bar makes the height of the bar proportional to the number of cases in each group. And the heights of the bar to represent values in the data, use GM call instead. What does that mean? Let's go to examples. This is GM bar. It's your regular old bar chart that just gives counts. Okay, here's GM call. Okay, so the GM call is maybe just more general then? You can get the means of each of these categories rather than the counts. Is that what they're saying with this? Maths debater 001, thank you for the follow. Oh, maths debate. It took me a second. Wow, that's a good one. I haven't seen that one before. Like, oh, I guess that person likes debating about maths. And maybe they do. I get how cooling system works, but like, really, we're experiencing worse temperatures in the future. This thing cannot handle 104 degrees Fahrenheit in a single day. Yeah, that's definitely going to be a problem. But I mean, it makes sense that like it can't handle any temperature, and I don't know. You can't make like a perfect machine. I guess it's gonna fail somewhere. No worries. Come and go as you need. Wait. I want to see. So GM bar, you can change the stat that it uses. So what really is the difference? Does one have like an extra parameter maybe? No, they have the same parameters. Hmm. Yeah, I don't think there's a big difference between GM bar and GM call. Not that I can tell, at least. Just the only difference seems to be their default parameters. Most geom stats come pairs that are almost always in concert. Make a list of all the pairs. What do they have in common? That sounds kind of tedious. GG plot geoms. Like there's a lot of geoms here. That making a list isn't trivial. I think I'm skipping that. I don't. Yeah. What variable does stat smooth compute? What arguments control its behavior? Well, it calculates smooth, which is just like a polynomial, like least squares type of thing. Oh wait, never mind. This is geom smooth, stat smooth. Just need to look at the documentation. Or not the description down below, but I want to see what the parameters are first. Uh yeah, I guess it calculates whatever method gives, like Lois or whatever. Oh. Oh, hey, here we go. After stat y or x, after stat ymin or xmin, after confidence bounds, and the standard error. Okay. In our proportion bar chart, we need to set group equal 1. Proportion bar chart. Which one was that? This one. So they have group equals 1 here, and they get this output here. If we chop that off, what do we get? Well, that's not good. It's actually, is this my issue? This might be my issue. With the first problem. Let's look at the other one they supplied to though. Yeah, they just all have the same beginning and end because they're not being grouped in any way. Oh, really? Does point range. Do you have a group thing? I guess not. That is like what my issue is though. Like it's not being grouped right. Hmm. Let's go to that then. I did have a different idea, like something about factor. Just try it and see what it spits out. Nope. Dude, that's gonna annoy me. I don't know what the answer is supposed to be. Is there an answer key? I feel like there's not. Suggested answer. Oh, hey. Wait, what? Oh, okay. All right. Spoil me. What am I on? Why are these chapter numbers different? I don't know. Same Fizzbuzz, yeah. Oh, this is a lot more complicated than I thought it'd be. Oh, you have to really spoon feed point range. Wow. Okay, I was way off. I'm glad I thought to look if there's an answer key. Okay, good to know. Hey, what's the explanation for group equals 1? Oh, they don't actually explain group equals 1. Okay. Alright, let's look at position adjustments then. One more piece of magic associated with the bar charts. Color bar chart using either color aesthetic or usefully the fill aesthetic. Yeah. Add the fill aesthetic to another variable like class. Bars are automatically stacked, which is nice. Position adjustment specified by position argument. If you don't want a stacked bar chart, identity, dodge, or fill. Exactly where it falls in the context of the graph, not very useful for bars because it overlaps them. Yeah. Any position argument is more useful for 2D geoms like points where it is the default. Okay. Oh my god, I just suddenly became so hungry. Position equals fill works like stacking. Each of stacked bars the same height. Oh, okay, yeah, this is like a proportional thing, I guess. Yeah, that's what they say, yeah. Dodge places overlapping objects directly beside one another. Ooh. This is a little disgusting, but maybe there's some context where that's nice. I don't think I'm a fan of that, though. So another type of adjustment that's not useful for bar charts can be very useful for scatter plots. Call our first scatter plot. Notice the displays only 126 points, 234 observations in the data set. I wonder if I don't actually notice that. Like, did someone count the number of dots? Unlike values of highway and decimal are rounded so the points appear on a grid. Many points overlap each other, known as overplotting. Equally throughout the graph, or is one special combination? I mean, does it? I feel like we're seeing the distribution of the data still. Phobos! Hello, hello. I hope that the rest of your code roast was chode-tastic. And you know, I hope your Saturday is chode-tastic also. You can avoid this grid by setting position argument to jitter. A lot of random noise to each point? No, why would you ever do this? This is like the worst solution I could think of. Oh my god, I hate this. Not enough chode today, but it's a good day. Okay. It is. So I'm trying to speedrun learning R enough to do a project with it. And so I found this like online like textbook basically. And so I don't know how far I'm going to go in it, but I want to learn enough to do something with R. So I have a specific idea. It's kind of complicated though. So if it comes from, there's a job that I applied to that would be doing data analysis in support of cancer research. And it's kind of like a glaring hole in my resume that I don't know any R and they want you to know R. I applied anyway, just because, you know, you should always just try to apply. But I would like to do the type of thing that they were looking for, which is it's a really cool job. It aside from streamer, it will be my dream job. And it's working for a nonprofit too, which is another huge plus. But yeah, so they want you to know about like tidyverse, which is what I'm working on now, but also this other package called bioconductor for R. And they want experience with something called RNA-seq data, which is RNA sequencing. And this apparently has relevance in cancer research. And so my plan was to learn enough R to go through this paper here and try and recreate some of their plots, because the data they use is publicly available. And so they have like this principal component analysis plot here that I want to recreate. That's pretty much my idea. And so I tried to just go straight to doing this, and I got really overwhelmed and stressed out, so I decided to start smaller. Go big or go home. I know. Like I could go big if I like used AI to help write this stuff, but I'd rather learn it more traditionally. Straight to the thesis. That's what Agent Chody Banks would do. So yeah, it'd be really cool to have a job like that. So I want something involving R that I can put on the old GitHub that would also be related to this. So it's kind of like two birds with one stone. In terms of like getting both experience with R and with this RNA sequencing data stuff. Yeah, I've done Python and Matplotlib, and I updated my GitHub a few days ago. Oops, what am I doing? Yeah, exactly. So I got a bunch of stuff on here now with like machine learning stuff I've done, principal component analysis. So I mean, I don't know if it will be a good subject for a roast, but you would be welcome to roast any of this. Like none of these code snippets are like super long though, and it's kind of like data analysis or scientific computing stuff. It's not like an application. Otherwise, I would have like suggested it for a code roast. But if you think you could like make it work, then be my guest. But yeah, like with R, it does a lot of things for you, and I'm kind of struggling with like figuring out the language they use to do all those things for you. I feel like I just have no control over it. You have AI to roast projects now. Wow, you could really pump them out then. Skill code roast. Code roast skill for your AI. Ask your AI to roast this code in projects you hold dear. Ask your AI how to install skills. Look at the issues. The closed ones. Too mean. Too mean for the person who surveyed the entire landscape of task managers, task warrior to do.txt, and decided the world truly needed was another one and go. Persisting data to a CSV file with cow say. Laughing what she tells me you already know. But really, I waited the roast from mild to medium was Chode's custom cow say module. Handcrafted specifically for this app. Apparently, existing cow say wasn't artisanal enough to represent your tasks. The code equivalent of whittling your own spoon to eat cereal. Then there's the file locking, concurrent write protection. Leveling implemented for a single user personal to-do list on one machine. Touch roughly twice a week when the guilt gets bad enough. If the roast failed, we consider that it was proportional to the confidence takes to ship a glorified CSV editor with ASCII cal output in the year 2026 and name it kill a task. Ugh. Oh my god, that's great. I'm sure it was a lot longer. That's hilarious, Phobos. It's this is just like a markdown file. Can you actually give this to AI and it'll learn how to roast code? Is there something that I'm missing here? It's that simple. Wow. Yeah, I never heard of this of a skill. Oh, I see. This is like okay. This is. I thought you was me, but you is the AI. Okay, that makes a lot more sense. Love it. It's not too hard. I mean, I assume you need like an AI installed on your machine. I had never done that before. The only interaction I've ever done with AI is like going on to ChatGPT on the website and like prompting it. Even that I haven't like done that much either. I've never heard of adding randomness to scatter plots. This is more revealing than this, according to them. Like, I guess because our like this looks too much like a pattern when it's not. This makes me so uncomfortable though. Like, why can't you just draw it properly if this is an issue? Like, why would you restrict yourself to a grid if it's such an issue? I don't get it. Or maybe the differences between data points are too small, so you just add more differences? I don't know. I that makes me uncomfortable that it's apparently useful. What is the problem with the following plot? How could you improve it? Let's see. Oh, there's not enough randomness in these points. We need some randomness. Uh, is that actually what their issue is with this plot? City versus highway. Like, the scale is kind of squished. I don't like that. I mean, that's true. Oh, the music just stopped. Um, there we go. Be able to vary them a little bit, some factor less than the standard deviation. That I mean, I guess that's what I don't know. Like what, like the scale of that. I guess this would be less than the standard deviation, but this feels like a problem that we created ourselves. Like just use a finer grid if it for this if it's such a problem. I don't know. It's just like a backwards way of doing it. I don't know. Of the measuring device, yeah. Or yeah, I guess I was what was I doing? I guess yeah, you have like two dimensions of standard deviation, like one for decimal, one for highway. Yeah, like you could definitely do that. Since it only gives you, oh yeah, so you could like safely do it by like 3 decimal points, I guess. Okay, so does geom_point have a parameter that says don't mess with my scales, please make them the same? Or maybe do mess with my scales, I don't know. Because with like what it's doing now, or it's scaling in such a way that like every relationship is going to look like it has a slope of 1 if it does have a linear relationship, or maybe -1. Hmm. This is not a geom point. Is it a GG plot thing I should be actually looking in? Maybe it is. Like, does the aesthetic? Does the aesthetic that goes in GG plot need to tell me this? Okay, thanks documentation for not telling me that. Okay, I don't know if this is if my idea is even what they're intending. So let's look at the answer key, because that's a thing that we can do now. You want me to jitter? Okay, let's actually. It did seem like there's a big difference though. Let's do the jitterbug. Okay, so this is pretty revealing for like what the issue is, like, or like why you want to jitter. I still don't understand why you don't just like this is just a bad choice of grid. I don't know. Like this must use a finer grid than this one does. Like this feels like such a backwards solution. I don't know. I must be crazy if like there must be something that I'm missing if I don't understand why you would want to do that still. What, if anything, is the difference between these two plots? All we're doing is adjusting... Oh, there shouldn't be a difference, because doesn't geom point default to identity? Let's find out. And that's that. And that's the same thing, because geom point, I think it defaults to identity. Probably already have it open somewhere. Nope. Nope. Yes? Yes. Yes. I think that question is kind of useless, but okay. Parameters to geom jitter control the amount of jittering. Width and height. There you go. Problem solved. What is the actual answer to this? Probably a very large number, girl that is small. Like I assume there's a not that window. That window. Good answer? Okay. Thank you. Each of those carrots is like another 3, I would assume. So that's what? 1, 2, 3, 4, 5 carrots. So 3, 1, 2, 3, 4, 5. Yeah, right. So like in the up arrow notation, would it be like 3 up 5? Or something like that? Between 2 and 300? No, it's way more than 300, I think. Not with that attitude. That's true. I did assume you're using base 10 numbers. Maybe that's a mistake. Can Wolfram Alpha do up arrow? Wolfram Alpha up arrow notation. You're not telling me how to do it. Up arrow. Aha. How does Mathematica work again? Okay. You don't understand me? No one understands me. I think Wolfram Alpha probably can't do it, but we could manually type it in. Three to the type of the way that you did. Oh yeah, let's see if Wolfram Alpha can do that. That's a good call. Nope. But could do this, I think. I hope I'm getting the parentheses right. Yeah. Last few. I wish you gave me scientific notation, Wolfram. It's probably too hard. It's just 5. Wait, no, this is not 3 to the power of 5 syntax, if that's what you mean. It's this. 10 to the 10 to the 10. So 10 to the 10. That's already 10 billion, right? And so we have 10 to the something more than 10 billion. Then another 10 to that and another 10 to that. Yeah, that's a massive... There's probably not a word for how big that number is. Hey, average bucket. Oh, okay. Yeah, that makes more sense, syntax. I bet you could make a formula for what the last digit is based on how many powers of 3 you have. I don't want to do it, but I think you could. I think I know it. Yeah, like at least for this first level of up arrow, I know that much. What's the second level of up arrow? Oh, oh God. These numbers are getting disgustingly huge. Wait. Oh, did I do this wrong? Oh. So it's actually double up arrow. It's 3 double up arrow 5, I guess. Not just one up arrow. Okay. Okay, I saw the reference to the Ackermann function, and I want to see what that is again. So I learned about it in my discrete math class, I remember. It's like one of the fastest growing functions we can come up with, I think. I mean, I don't know if that's a true statement, but it's a really fast growing function at least. Come on, Wikipedia, please load. Oh, is tree 3 another, like, fast-growing one? Okay, Wikipedia doesn't feel like loading. Does this Wikipedia feel like loading? No, it doesn't. Annoying. Let's see what Josh Kerr has to say about it. Is this a blackboard? Looks like a piece of metal you find on the side of the road. Julian K120. Hey, it's going good. How about you? Welcome in. Okay, get to the interesting stuff, please. This reminds me of, like, when you look up a recipe, they have a whole thing that you don't care about before they actually get to the recipe itself. It's good to hear, Julian. Ooh, it's a lot of digits. Even close to Graham's number. Ooh. G64. You need 64 up arrows? Or 63, I guess? Wait, no, G1. Wait, what? Oh, wait, this is recursive. Oh my god. So you start with 4. Wow. Okay, yeah, that's... I don't... we could calculate how many arrows that is. I can't work it out in my head right now, though. Googology? Big number garden? Okay. The tree function is complicated. The function returns a large sequence of trees you can build. I probably shouldn't have skipped. I think the stuff before this was important. Well, G1 is already so big we couldn't write it down. Yep. Prediction grows fast. Increasing very big numbers. Conway's chained arrow notation. Calculate the height of the tower. Okay. This is faster than up arrow notation. Oh, okay. He's not going to explain it. Oh. Sure. Whatever that means. It's actually really small compared to tree 3. Oh my god. Okay, never mind. We could have skipped that. This feels like a really, like, prideful thing, just to make the biggest number you can think of. Function returns the largest sequence of trees you can build, given an input number, different types of seeds you can use to build them. This is a little too metaphorical for me. Large number, garden number. That doesn't really roll off the tongue, but okay. Okay, tree of 1 is 1. Tree of 2 is 3. We're off to a good start. Not too bad. Tree of 3. Number so big it dwarfs Graham's number. Wow. Got an actual response from a professor. Talks about graph theory. Okay. Returns the longest possible tree made with n elements that follows very specific rules. Rules guarantee the resulting longest tree sequence is finite. Yeah, this is too layman for me. Let's look at the stack exchange thing, maybe. That's true. Asking why math is the way it is, it's kind of a pain. Difficulty of a beginner's explanation. Right. A function on ordinals that outputs fast-growing functions. Sequences of unlabeled trees. Labeled trees goes even faster. Oh god. Okay, never mind. I don't want to read all this. This is... Okay. I'm gonna give up on this. There's some interesting stuff here, but I think I don't want to read all this. Julian, so I just graduated with a master's in applied math. So I'm best with like differential equations and like calculus type of stuff. I'm happy to at least attempt to talk about anything people in chat want me to. There's a lot of things where I just kind of throw my hands up and go, I don't know, like I just did with the tree function. It is cool that this exists though. It's just kind of a little too difficult and technical for me to want to get into it. Yeah, so the theme of the stream is we talk about math. Like my favorite thing to do is like homework help type of stuff. But if someone just wants to like have a chat, that's also cool too. If there isn't someone in chat who's like prompting me to talk about something, I'll kind of choose my own subject to like study. And so recently that's been trying to learn R to do some data analysis stuff. I have not done anything with chaos and fractals. I am really interested in learning more about them. So they apparently have some relation with differential equations or something that I don't know. But someone who knows a lot about them, or at least more than I do, and also and loves them, is Zach, aka Eats the 2i Pie. So if you don't know him already, I highly recommend you follow him. You just missed him doing a question and answer stream today, actually. And if you still want to ask me something about chaos and fractals, please do ask me, and we can do some Googling and always try and talk about it, just like I did with the tree function. But you might get more mileage from asking Zach. Let me see. Does he have posted when he's going to stream next? He'll do a math stream on Tuesday, starting 15 minutes ago, whatever that is in your time zone. This is next like scheduled math stream. Yeah, feel free to post your question here too, though. I just can't promise that I'll be able to answer it. And actually, before I forget, since I do see that you were a first-time chatter, in case you don't know already, this niche exists here on Twitch of math streaming. It's not just me. So this list is kind of a lot and it's overwhelming, but that's what most people I can like recommend highly. There's even more people than just that too. Um, but whenever I see a new face, I like to let them know that it's not just me who does this here. There's a whole community of us, and we all have like our own strengths and weaknesses. No worries, girl. Let us know. Good luck with whatever else you're doing today. Um, I don't know if anyone who knows about Googleology. Unfortunately, I'll keep an eye out. If I see anyone, I'll tell you. But I don't know of anyone offhand who knows about Googleology. Oh yeah, absolutely. Echo, hit me with it. Let me get some water in the meantime. Okay, abstract algebra, complex analysis, introduction to programming, Python/Julia, and algebraic topology. Wow. That sounds like a really full course load. um Complex analysis, I love it. It's such a beautiful subject. I think it's easy to love. I personally would have a hard time with abstract algebra and algebraic topology because I'm just not very good at like theory. You know, the complex analysis that I know wasn't super theory heavy, but it can be. Yeah, it's just a nice subject. I haven't heard of anyone who says that they dislike complex analysis. Um, but yeah, that those all sound like great courses to take if you're interested in them. I that would abstract algebra and algebraic topology would be a nightmare for me probably because I'm also imagining that like those are not going to be easy versions of that class either, from what I've heard so far about your university. Abstract algebra was mandatory and you dropped out of that last semester. You have to push through this time. It's not easy stuff. They can really grill you with some of those proofs. I've only done some very basic like group theory stuff, and like I can work my way around like the easier proofs, but I struggle to enjoy it, and I also struggle to do it after a certain point. Professor is doing complex analysis, algebraic topology is the one who's doing functional analysis. Oh no. That's gonna be difficult. Good luck. I don't know what else to tell you there. She's more on the geometric side of things, probably getting more focused on differential topology. Hmm. Yeah, I don't know. I never did any sort of topology, so I'm not sure what the different flavors even look like. Oh my gosh. I'm getting tired. But yeah, I mean, it's good stuff though. Like, hopefully the professor for complex analysis and algebraic topology isn't going to super overdo it like it sounds like she's doing with functional analysis. But those are good courses. And yeah, there's a lot of things on my math bucket list for things that I want to learn about, and at least some basic topology is one of the things on it. Topology it just sounds very strange. From the bit of it that I know, talking about like deforming shapes into other shapes, but it does seem to come up like in a lot of places in math. So she's absolutely gonna overdo it. It sounds like it, yeah. um, I'm getting kind of hungry and tired. I might wrap things up here, to be honest. So if anyone has any like last minute things that they want to get in here, let me know. But um, yeah, I think we'll maybe look for someone to raid. Thank you, thank you, Echo, and good luck with your courses. So YouTube stream will get turned off here. People in your YouTube, thank you for being here.